If you fly over western Poland, you will see a lot of this. Dense, thriving pine forests. The trees reach up perfectly vertical, fighting for a spot in the canopy. But in one specific isolated patch near the town of Gryfino, the rules change. Here, roughly 400 pines have identical, sweeping, J-shaped curves at their bases. To understand why this is so bizarre, we have to look at a biological baseline called gravitotropism. It's essentially a plant's internal compass. As gravity pulls down on the roots, the trunk is programmed to grow in the exact opposite direction, straight up toward the sun. The pines in this forest completely ignore that compass. Instead of growing vertically, the trunk sweeps horizontally, right out of the ground, entirely defying gravitational pull, before finally correcting itself. And hundreds of them make this exact same biological error in unison. Because there are no living witnesses to tell us what happened when these saplings sprouted in the 1930s, we are left with a forensic debate. Did a chaotic force of nature cause this, or were these pines deliberately engineered? The first suspect usually brought to the table is the terrain itself. Could a localized gravity anomaly be pulling the young trees off course? The physics quickly eliminate that idea. Gravity exerts a force straight down, not sideways. Plus, if the Earth's pull was somehow distorted here, the perfectly vertical trees growing directly adjacent to this patch would also be deformed. If the ground didn't pull them down, maybe the sky pushed them down. The leading natural theory points to a freak winter storm. You see, young pine saplings are incredibly flexible. If massive snow accumulation dropped during a severe winter, the sheer weight can pin the saplings entirely flat against the earth without snapping them. This chart compares lateral growth angles against seasonal data. When a sapling gets trapped under heavy snow, it enters a survival mode. It grows horizontally beneath the weight just to stay alive. Once the spring thaw finally arrives and the weight melts away, the tree abruptly resumes its vertical path toward the canopy. Snow weight provides a mechanically sound explanation for the bend itself. But weather is notoriously messy. It scatters debris and snaps branches in random directions, which fails to explain the sheer perfection of this grove. When nature acts, it rarely does so with mathematical precision. Are these curves simply too perfect to be the result of a random weather event? The biggest flaw in the blizzard theory hides in the geometry of the forest. Every single one of these 400 curved trunks points exactly due north. A random snowstorm doesn't consult a compass. In the early 20th century, pre-war farmers in this region approached forestry as an industrial process, intending to harvest specific shapes rather than raw lumber. Foresters of the era practiced an early form of bioengineering. By systematically strapping mechanical weights, specialized wooden clamps, and tension ropes onto a sapling, a farmer could force the young tree to adopt that specific J-shape over time. They did this because pre-bent wood was incredibly valuable. Straight lumber is easy to mill, but cutting a curved piece out of a straight log severely weakens the grain. Allowing a trunk to naturally grow into a sweeping shape provided structurally superior timber for crafting the curved internal ribbing of ship hulls. Beyond shipbuilding, local artisans and carpenters paid a premium for the specialized timber to build custom furniture, utilizing the natural tension of the wood for sturdy chair legs and barrel hoops. Between the strict northern alignment of the trunks and the high economic demand for curved wood, the data builds a highly compelling case for deliberate human engineering over a random blizzard. We have two plausible scenarios facing off: the harsh biological reality that heavy snow can pin a sapling versus the mechanical precision of the human tool theory. But if this forest was a coordinated human engineering project, why is there absolutely no documentation? No logging records, no discarded clamps, and no locals claiming the cred. The answer lies in the timeline. These trees were planted in the 1930s. Shortly after they began to grow, World War II reached Gryfino. The local town was completely decimated, reduced to rubble during the conflict. When the town fell, its history was wiped clean. The farmers who planted the forest, along with their specialized tools and logs, were permanently erased. By the time the area was resettled, the new residents found a fully grown, inexplicably crooked forest with no instructions attached. It highlights a frustrating limit to modern science. We can run biomechanical stress tests, plot meteorological data, and analyze physics proofs. But catastrophic historical events can still sever the chain of evidence, leaving us entirely blind to the truth. You've seen the evidence, the chaotic aftermath of winter storms versus the cold precision of industrial forestry,